and I would like to come to the center next year. The deadline for the postdoctoral fellowship and the visiting fellowship is December 10, and you can find all the information on the center's website. Now it's my great pleasure to introduce Margherita Harris, who is right now a postdoctoral fellow at the center. So she's been with us for now a few months. She got her PhD in 2021 from the Department of Philosophy, Logic, and Scientific Method at LSE. And she works on a range of topics, modeling under uncertainty, robustness analysis, often with a focus on some case studies, climate science being one of them, and we'll hear more about that today. She also has some very serious interest and expertise on the foundations of statistics. I suppose as well. The floor is yours.
Thank you for coming. I'll just start. So, okay, so studies of climate change are affected by deep uncertainty, communication which is made even more broad by the study's immediate policy implications. I can still do policies, but it's okay. So the world of policy making is demands that certain communication should be communicated in a simple, consistent, and relevant manner. So, to address this, the latest IPCC assessment report makes extensive use of calibrated language in its findings. So in some cases, both the likelihood and a confidence term are used to get a certain finding. In some other cases, only a likelihood term is used. And in other cases, still only a confidence term is used. And so the presentation of these findings gives rise to several questions. Oh, you can see the question marks. Okay. What do these confidence and likelihood terms mean? Are they supposed to represent different types of uncertainty? And so, what types? Why is a likelihood assigned in some cases, but not in others, like in finding 2, but not in finding 3? And what does it mean to claim that the global mean sea level rise is likely in a range with medium confidence? If the IPCC only has medium confidence, should we believe that this is indeed the likely range? So this talk stands for investigation into these questions, and it's outlined as follows. I will first start by giving a brief overview of the IPCC uncertainty framework. And I should mention at this point that although the IPCC uncertainty framework has gone through considerable revisions before each of the previous 3 major assessment reports, the decision for some reason was made not to update the framework before the commencement of the latest and 6th IPCC assessment cycle, which means that the current IPCC uncertainty framework is actually the same that was used for the previous 5th IPCC assessment cycle more than a decade ago. Okay, so I do that, then I will argue that the IPCC uncertainty framework has what I consider to be serious conceptual problems, and in particular, I will argue that some of the IPCC uncertainty guides recommendations are incompatible with any possible interpretation of the likelihood and confidence metric. I will then argue that these conceptual problems have worrying implications, very worrying implications, for both the IPCC's treatment of uncertainties and also the quality of the information provided in IPCC reports. And in particular, I will discuss particular practice in how the IPCC handle uncertainty cells. Raise the attention of several philosophers already, but I will argue that philosophers express some concerns about this practice. Well, they have what about this practice for the wrong reasons, so to speak. And I will argue that the only reason why we should be very troubled with this practice has to do with what Philip Stark calls quantification, which is a neologism for the common practice of assigning a Lynch number, then concluding that because the result is quantitative, it must mean something. Then I will assess 2 strikingly different proposals for a new IPCC uncertainty framework, and I will argue that both are conceptually problematic for distinct but related reasons. In particular, I will argue that in both proposals, the interpretation of or confidence is conceptually problematic. And if I have time, but I might not, I will offer my own tentative proposal for what I consider to be, could be an adequate IPCC uncertainty framework. Okay, so the IPCC uncertainty framework provides two uncertainty scales for the IPCC authors to communicate uncertainty in their findings. The confidence scale is a quality scale with 5 levels, ranging from very low to very high. Increasing levels of evidence and increasing degrees of agreement are correlated with increasing levels of confidence, as shown in the picture. Oh, let me see. In the picture provided by the diagram provided by the guide. So the evaluation of evidence, according to the guide, depends on 5 criteria, namely the type, amount, quality, consistency, and independence of the available evidence. The evaluation of agreement, what the evaluation of agreement depends on, actually, the guide does not specify. However, in an additional IPCC document, it is said that the degree of agreement is meant to express a measure of the consensus across the scientific community on a given topic and not just across an author team. There's a lot to say about the confidence scale, but I don't have time for that. So, next one. The likelihood scale is a quantity scale with 7 levels, ranging from exceptionally unlikely to virtually certain. Each level corresponds to a probability interval as shown in the table provided by the guide. And according to the guide, the likelihood metric is used to express a probabilistic estimate of the occurrence of a single event or of an outcome, and it may be based on statistical or modeling analysis, elicitation of expert views, or other quantitative analysis. And that's all that the guide has to say about the likelihood scale. In particular, no interpretation of probability is offered in the guide. Okay. Now, the guide also has quite a few recommendations for when to use both the likelihood and the confidence scale. But I will only mention 2 that are important for what I'm going to argue in this talk. So the first recommendation is the following. The guide basically prohibits, which is an important one, so remember this one, it prohibits authors from reporting likelihood if confidence is not sufficiently high. So if confidence is not high or very high. And now, interestingly, although this recommendation is mostly followed by the IPCC authors, it seems, this is not always the case. For example, in this finding, a likelihood term is used, but the confidence is neither high nor very high. But the second recommendation, so the guide also says that an explicit mention of the level of confidence is not required as long as confidence is sufficiently high. And this may explain why there are many cases in which we only see we see findings in which only a likelihood term is used. Perhaps the level of confidence associated with this finding was sufficiently high for the IPCC authors not to be required to explicitly mention it. Okay, so we've seen that the IPCC guide has 2 uncertainty scales for the IPCC authors to communicate uncertainty in their findings, and the following question arises. What is the relationship between the scales? In other words, are the confidence and likelihood metrics supposed to represent different types of uncertainty, and if so, what types? As much as we might wish for an ambiguous answer to this question, the IPCC guide does not provide one. And to make things worse, I will argue that there is no conceptually coherent interpretation of confidence and likelihood that is in fact compatible with some of the guide's recommendations. Okay, so according to Jones, who is a lead author, was a lead author on the 3rd, 4th, and 5th IPCC assessment report, the confidence likelihood metrics of the uncertainty guidance form an epistemological ontological structure. Confidence is epistemological and likelihood is ontological. The twin basis for key scientific finding combines ontological reasons, what the author team knows, and epistemological reasons, how confident are they in that knowledge for a particular conclusion. Now, Jones' terminology here is admittedly a little odd, given that usually we think of epistemology rather than ontology as concerned with knowledge. But I think what Jones really means to say here is that The likelihood metric is ontological, that is, it expresses objective facts about the world. The confidence metric is epistemological. It expresses the IPCC author's confidence that the best theories offer a truthful reflection of this fact. So, to understand this interpretation at this point, we need to make a distinction between subjective and objective interpretations of probability. So, a fairly uncontroversial assumption in philosophy is that in interpretations of probability fall into two broad categories, families. So, subjective interpretations view probabilities as dependent on the mental states of individual agents. These probabilities are referred to as subjective probabilities, credences, or degrees of belief. And objective interpretations view probability as features of the mind-independent world. These probabilities are usually referred to as subjective probabilities or chances. So if Jones is right and likelihood is ontological, then the right interpretation of probability as far as the likelihood metric is concerned should be an objective one. So, under this interpretation, then confidence and likelihood are understood as representing different types of uncertainty, whereas the likelihood metric expresses the objective fact that the chance of the occurrence of the event is in a particular interval. The confidence metric expresses the FCC of this confidence in the truth of this fact. Under this interpretation, so consider again this finding. Under Jones' interpretation, what it would mean is the following. The world is such that the chance that the global mean sea level rise would be in the range 0.9 to 1.88 meters in the interval 0.661, and the IPCC authors have medium confidence in this claim. Now, however, as Winsberg argues, given the nature of climate science, one might question, they very well question the idea that that likelihood can express something objective about the world. So perhaps we should not think of the probabilities in the IPCC assessment report as objective after all. But this is troubling because if likelihood is not ontological as just claims, then it's no longer obvious how one should interpret this finding. So the question is there another way to interpret this finding? Could we perhaps think of the 0.66, the interval 0.61 as imprecise subjective probabilities representing the IPCC author's credences that the global mean sea level rise will be in the range 0.98, 1.88 meters. But in that case, what should we think of the qualifier? Medium confidence. Now, as I will discuss later in my talk, Winsberg has proposed a particular interpretation of confidence under this understanding of likelihood, but I will argue later that this interpretation is conceptually problematic. So, for the purposes of what I'm arguing so far, I'll just assume that the level of confidence is merely an additional evaluation of the evidence that was used to determine the range of credences that one ought to have in a hypothesis. And Avon causes the strength of the knowledge supporting a subjective probability judgment. Okay, so let us now follow each of these two distinct candidates for possible interpretation of likelihood confidence and see whether it is, particularly see whether either is compatible with the guide's recommendation to assign likelihood only if confidence is sufficiently high. Consider Jones' interpretation first, where likelihood is ontological. This interpretation seems incompatible with the IPCC's recommendation to assign likelihood only if confidence is sufficiently high. And this because if likelihood expresses the objective fact that an event or an outcome has a particular chance, then there seems no plausible reason for discouraging authors from communicating this fact, even when confidence in the truth of this fact is not sufficiently high. For instance, suppose I have medium confidence in the objective fact that a coin is biased towards heads. For example, the hypothesis, so I have medium confidence in the hypothesis that the coin is likely to land heads. So if I can't report likelihood in this case because my confidence is not sufficiently high, and oh god, what did I do? Oh, sorry. What should I say about this coin? So if I just claim that I have medium confidence, it seems like I'm omitting essential information. The medium confidence was a statement about the finding the coin is likely to land heads. So if I just say, if I just report confidence, I would be failing to report the finding that I have actually medium confidence in. if you see what I mean. Okay, so we can discuss this further later, but let's move on to the second interpretation, where likelihood is epistemological. Because under this interpretation, confidence is supposed to be some sort of evaluation of the evidence that is used by the IPCC authors to determine the range of credences that one ought to have in a hypothesis. But then in cases where confidence is deemed not to be sufficiently high and likelihood is not assigned in accordance with the guide's recommendation, it's not at all clear how one should interpret a finding. To clarify my concerns here, consider this particular finding from the previous IPCC report, which says there is high confidence that sustained warming greater than some threshold would lead to the near complete loss of the Greenland ice sheet over a millennium or more. The threshold is greater than about 1 degree Celsius, low confidence, but less than about 4 degrees Celsius, medium confidence. No likelihood is assigned in this case, so it is very clear how one should interpret this finding. Do the IPCC authors think that, for example, the threshold greater is likely greater than about 1 degree Celsius, extremely likely greater than about 1 degree Celsius? Do they think that the threshold is extremely likely less than about 4 degrees Celsius, etc., etc.? So without an answer to these questions, it seems impossible to understand the meaning of this statement. So it seems to me that both of these possible interpretations of likelihood and confidence are incompatible with the IPCC's recommendation to report likelihood only if confidence is sufficiently high. And given that I can't really see any other interpretations of likelihood and confidence that are compatible with this recommendation, and I'm tempted to conclude that the problem is not my lack of imagination, but that the problem is that uncertainty is not adequately conceptualized. I will now try to convince you that the lack of a conceptually valid interpretation of the concepts of confidence and likelihood in the IPCC uncertainty framework has very serious and worrying implications for both the practice of the IPCC authors in the treatment of uncertainties and also the quality of the information provided in IPCC reports. Okay, so there is a particular practice of the IPCC authors to do with how they handle uncertainties. And that I believe has something to do with the guide's instructions to report likelihood only if confidence is sufficiently high. And I will now try to convince you that we should be very careful about this practice. So consider, for instance, these projections from the previous IPCC report for one of the most important indicators of global climate change. How did IPCC authors arrive at these projected ranges for the global mean surface air temperature? In a nutshell, this is how they did it. They took a group of models and they computed the mean and the standard deviation of their prediction. They then constructed a normal distribution with the same mean and standard deviation and took the 5 to 95% range of that distribution. Finally, they interpreted this range as the likely range instead of the very likely range as it would follow from the IPCC calibrated language, if you remember the likelihood, because that would be 90. Anyway, trust me. Now, these multi-model ensemble methods have been common for a very long time. And although there's been an attempt in the 6th and most recent IPCC report to use additional lines of evidence for the global mean surface temperature in particular, many important projections in the current IPCC reports still heavily rely on these methods. And here's a couple of quotes from distinct chapters of the IPCC report, the current IPCC report, to convince you that this is indeed the case. As you can see, in both chapters, it is claimed that the default was to interpret the 5 to 95 model ensemble range as the likely uncertainty range, as in the multi-model ensemble methods just described. So, philosophers and scientists who have commented on this practice have all described it as a case in which the IPCC authors are downgrading likelihood in order to upgrade confidence. I didn't have time. This is a quote from Mac and colleagues, but I didn't have time to. Anyway, they all claim that. And there are two main concerns that have been raised in the literature when it comes to this practice of downgrading likelihood, thereby upgrading confidence. This concern. Okay, so the first one has to do with the lack of transparency behind this practice. Like the question is, what determines how much likelihood should be downgraded when confidence is upgraded, and what are the relevant considerations? And the other one has to do with the lack of ambiguity of this practice. Indeed, notice that although there are cases in which there are conditions for the guide to report likelihood or in cases where confidence institutionalized is not followed by the authors, as in this case, and where likelihood is reported only with medium confidence. And this has puzzled philosophers. Why are the IPCC choosing to upgrade confidence in some cases by downgrading likelihood, but not in others? What is it determining the IPCC's choice of the confidence level at which to communicate a finding? In particular, if confidence levels can interact with the likelihood assignments as the practice of the IPCC authors suggests, then some have argued that the choice of reporting findings at a particular confidence level seems to involve substantial non-epistemic value judgments. For instance, according to Winsberg, it seems clear that sometimes it is considerations of the likely applications of an uncertainty report that guide the choice between a wider and more confident report and a narrower and somewhat less confident report. And the worry here is that such considerations should be made explicit and open to scrutinization. Okay, but I would worry that, in contrast to what philosophers are worried about when it comes to this practice, that the real problem is neither the lack of transparency behind this practice, nor the possible involvement of substantial non-epistemic value judgment, but that the problem with this practice has to do with what statistician Philip Stark calls quantification, which is a neologism for the common practice of assigning a millions number, then concluding that because the result is quantitative, it must mean something. Quantification usually involves some combination of data, models, inappropriate use of statistics, and logical acumen. So why do I think this? To see this, let's take a step back and think about what these multi-model ensembles methods are really all about. Because at the ranges that we see in this finding are obtained by simply taking a group of models, computing the mean and standard deviation of their predictions, and then taking the 5 to 95% range of a normal distribution with that same mean and standard deviation. However, as several have pointed out, it is unclear what could possibly justify this practice. For one, it is very unclear where the assumption of the normal distribution comes from. The normal distribution is often legitimately assumed when calculating a confidence interval for a variable. However, as Stark remarks, that is not a confidence interval for anything, and the previous statement is a further mangling of the interpretation of confidence interval. If the collection of numbers were a random sample from some population, and if that population has Gaussian distribution, or if the sample size is large enough that you can invoke the central limit theorem, then the interval would be an approximate confidence interval for something. But if the list is not a random sample or a collection of measurements with random errors, there is nothing stochastic in the data, and hence there can be no general confidence interval. And if these methods derived from this, if the ranges derived from these methods are not meant to be confidence intervals, then it is very clear what they're meant to be in the first place. But regardless of how we should interpret these ranges derived from these methods, as Winsberg remarks, the average and standard deviation of a set of trials is only meaningful if the trials represent a random sample of independent rows from the relevant space, in this case, the space of possible model structures. And as Winsberg himself and several others have argued, this assumption is simply implausible. So I think it's safe to say that no one, including climate scientists, thinks that these methods are conceptually coherent methods for producing probabilities. And yet, instead of simply choosing not to rely on them, the IPCC authors choose to account for the lack of any justification for relying on these methods by simply declaring the ranges derived by these methods to be likely instead of very likely, as it would follow from the methods they use to derive those ranges. And that's, I think, all there is to this practice in my view. And in other words, my claim here is that the downgrading block in this case is neither based on mysterious considerations that should be made explicit, nor on substantial non-epistemic value judgments that we're not aware of. Rather, the algorithm likelihood is simply a way for the IPCC authors to avoid having to critically reflect on the methods they're using to arrive at what they report to be plausible ranges for many climate variables that we see in IPCC reports. And because of this, I claim that the resulting probabilities that are attached to those ranges are neither subjective nor objective probabilities, and hence, in my view, they're not probabilities in any sense of the term, and calling them so doesn't make them so. Okay, so I think all this is very troubling, and I believe that the current IPCC methodic framework guide, which not only fails to provide a clear and unambiguous interpretation of both the likelihood and the confidence metric, but also, as argued earlier, makes recommendations that are incompatible with any conceptually coherent interpretations of likelihood and confidence, is partly responsible for the IPCC widespread reliance on quantification, since it fails to discourage this practice and it might arguably even encourage it. Hence, in light of all this, I think the question of what an adequate uncertainty framework for the IPCC should look like is a very important one, and so I will turn to that very question. So in the second part of this talk, I will critically assess the extent to which some recent proposals for a new IPCC uncertainty framework are an improvement over the current one with respect to what I consider to be some basic desiderata that any adequate uncertainty framework should satisfy. The first is conceptual coherence, which says the framework's fundamental concepts should be clearly defined so they can be used appropriately and consistently by the IPCC authors in communication of uncertainty. Decision relevancy is the second one. The use of the framework's fundamental concepts should help the IPCC authors produce findings that are interpretable, relevant, and useful for the target audience. After arguing that the two proposals that I'm discussing in this talk do not meet those desiderata, I will offer, if I have time, my own tentative sketch for a proposal that may be able to meet them. Okay, so as briefly mentioned earlier, Winsberg proposed a particular interpretation of the likelihood and the confidence metric in the IPCC uncertainty framework. But before explaining what this proposal is about, I should mention that Winsberg doesn't seem to think that he's actually offering an altogether new proposal for the IPCC uncertainty framework. Instead, he thinks that he's offering up what he considers to be a plausible interpretation of the current IPCC uncertainty framework. However, I don't think there's any evidence to suggest that this is plausible, but for two main reasons. One, the first one is that Winsberg interpretation is also incompatible with the guide's recommendations for essentially the same reasons that I discussed earlier in my talk. Secondly, Winsberg proposes a rather advanced epistemological interpretation of confidence and likelihood, and there is absolutely no good evidence that should want to believe that the IPCC has anything remotely close to what Winsberg has in mind. So, despite what Winsberg may think about this, I think the only reasonable way to interpret his account of confidence and likelihood is an altogether new proposal for the IPCC uncertainty framework, which I will now introduce. So, according to Winsberg, the likelihood metric should be used to communicate the range of probabilities that is satisfactory to almost all, if not all, of the members of a panel. Group credence, in other words, should be considered to be the number or range of numbers that is the consensus of the group regarding what one's degree of belief in the hypothesis ought to be. What about confidence? Here's where things get interesting. According to Winsberg, the confidence metric should be used to communicate how likely the panel's consensus regarding appropriate credences is going to remain fixed in the light of future developments. In other words, according to Winsberg, confidence should be thought of as a kind of second-order probability, since in effect it would reflect the panel's estimate of the likelihood of their credence changing in the future. So, for the purpose of what I'm going to argue in this talk, I'm happy to assume that Winsberg's interpretation of the likelihood metric is clear enough. So, in this talk, I will just the assessment of this proposal would exclusively focus on the confidence metric. Okay. So how is confidence supposed to be evaluated under Winsberg's proposal? Winsberg suggests that there are three factors that policymaker or any other decision maker might want to know in addition to the range of credences that an IPCC panel assigns to a hypothesis in light of the available evidence. One is how many different sources of evidence were consulted by the experts to arrive at the assessment of probability. The second one is how univocal all the contrary those various sources were, and a third one is the degree to which the reported consensus of the committee favored over internal disagreement, or to the contrary, reflected easy to come by agreement. According to Winsberg, all three of these factors are in principle independent. There could be many sources of evidence that disagree, a few sources that agree. There could be agreement or disagreement among the experts either way. Thus, in principle, the policymaker might want to use all of this information as a guide to how she should act. She might use the added information in conjunction with the political policies in a variety of ways. It doesn't specify which ways. More conveniently, though, the policymaker you might want the committee to summarize these three components of information into one single metric. That is the confidence metric. So what Winsberg, so under Winsberg proposal, the role of the confidence metric is to summarize these three factors just mentioned into a single metric in one way or another. And crucially, the reason why he claims that the relation of confidence under his own proposal is useful to policymakers is that one way to think about this kind of self-assessment of confidence is as the committee's assessment of the degree to which the answers to the above questions foretell a resiliency in their credences, as an assessment of how likely their consensus regarding a probability is going to remain fixed in light of future developments. One possible way to understand measure of confidence, therefore, would be as a kind of second-order probability, since in effect it would reflect the final estimate of the likelihood of their credence changing in the future. So, Winsberg is effectively arguing that if the role of confidence is to summarize those three factors just mentioned into a single metric, then it is reasonable to suppose that the level of confidence that the PC authors assign to a finding is positively correlated with the extent to which they believe that their credences in our hypothesis will remain fixed in light of future evidence. However, with interpretation of what the confidence metric is supposed to represent, under his own proposal is, according to me, conceptually problematic. So leaving aside the details of how the bad factors should be evaluated and the questions that each of them raises, it is extremely clear what basis Winsberg can argue that under these proposals is a reasonable interpretation of confidence. Arguably, Winsberg here is inspired by the Bayesian's everlasting attempts to show that as the amount of evidence, often lightheartedly referred in the literature as the weight of evidence, increases, an agent's credence in a hypothesis tends to become more and more resilient. However, this can be a reasonable idea only in cases where the agent's credence in a hypothesis is mediated by objective chances, and hence the credence in that hypothesis can be interpreted as the expectation of the hypothesis chance, and it is that expectation that tends to become more and more resilient as the weight of evidence increases. Let me give an example to explain what I was talking about. So consider an example that is often used to motivate this idea, and that many of you have probably heard of already. Popper called it the paradox of ideal evidence, and it goes roughly as follows. John is presented with a coin and thus to assign a probability to the proposition H that it will come up heads next time it is tossed. He doesn't know whether the coin is fair or whether it's biased towards heads or tails. So in light of the sequence, he assigns a probability of a half to H. So his priors in H is a half. He's then allowed to toss a coin 1,000 times, and he gets about 50% heads and 50% tails, and call this evidence E. Then the probability that he assigns to position H that the coin will unheads next time it is tossed is still a half. So his posterior credence in H is still a half. So after observing the coin being tossed 1,000 times, John has considerable more evidence concerning the proposition H that the coin will come heads next time it is tossed, and yet this is not reflected in John's credence in H. However, as many Bayesians have pointed out, it is nonetheless reflecting the resilience of his credence in H. So, although evidence has not affected the probability that John's assigned to proposition H, it has affected John's credence in other hypotheses. The difference between the evidence situation and the ideal evidence situation is that in the former, John assigns a new uniform probability distribution to the chance of the coin landing heads, whereas in the latter, John assigns a distribution which is sharply concentrated at where the chance of H is equal to a half. And despite this difference, however, both the ignorance situation and the ideal situation, John's credence in H is a half. So the expectation of the chance of the coin landing heads is a half in both cases. So in a nutshell, in the above example, the reason why weighted evidence tends to increase the resiliency of an agent's credence in a hypothesis has to do with the effect that the weighted evidence has on the agent's beliefs about the objective chance of that hypothesis. And it is due to this effect that the agent's expected value of the chance, that is their credence, tends to become more resilient as the weight of evidence increases. However, there is no analogous story to be told in case in which an agent's credence in a hypothesis is not mediated through the beliefs about objective chances. And hence, this example does not give us any reason for thinking that the weight of evidence should manifest itself in the resiliency of an agent's credence in a hypothesis in those cases. And I'm certainly not alone in thinking it is implausible to assume that the weight of evidence should always manifest itself in the resiliency of one's credence in a hypothesis, and neither is Winsberg in suggesting the contrary, as the following quote from Professor in Law and Clinical Justice Dale Nance should convince you of. So that's what he said. It's a mistake to identify the idea of Canadian weight with the idea of resilience. The two ideas are distinct, and though there are causal connections between them, the dependence relationships are complex. We should not therefore embrace the suggestion by Davidson and Parker that Canadian weight be identified with resilience of probability. Okay, in fact, I think some very basic considerations should be studied to be plausible. Indeed, notice that in this example, the agent's credence in the hypothesis tends to stabilize around the actual chance of the hypothesis. But in cases where there are no chances involved, the agent's credence in the hypothesis can't stabilize around the chance of the hypothesis for the reason why. The hypothesis that true or false, and the best one can hope for is that as the weight of evidence increases, the agent's credence in that hypothesis will tend to get closer to 1 or to 0, depending on whether the hypothesis is true or false. And even that is just a hope. But so recall that under Winsberg's proposal, the line of metric is supposed to communicate the range of credences that most, if not all, experts agree it is reasonable to hold in an hypothesis given the available evidence. So, under Winsberg's proposal, if the IPCC experts claim that the equilibrium climate sensitivity is likely to lie in the range of 5 to 4 degrees Celsius, this means that according to the IPCC experts, the range of credences that one ought to hold in the hypothesis that the equilibrium climate sensitivity lies in the range 2.5 to 4 degrees Celsius, given the available evidence, is 0.661. This interval, the interval 0.661, is not the expert's estimate of the expected chance of the hypothesis. Hence, there is no reason for supposing that a high level of confidence somehow based on the evaluation of those two factors is supposed to give any indication whatsoever of whether or not the range of credences that the experts assign to that hypothesis will remain fixed in light of future evidence. Okay, so to be clear, this is not to say that experts may never have good reason for believing that the credences that they currently assign to hypothesis is going to remain fixed in light of future evidence. For instance, here's a remark by Sherwood and colleagues concerning the very recent attempt to combine various different lines of evidence with a Bayesian approach to arrive at a unique posterior PDF for the equilibrium climate sensitivity. And they say some of the effects quantified in this paper with the help of the general circulation models were looked at only with 3 TMIP6 models, and interpretation of evidence might have to shift in the future upon further analysis of new models. But we would not expect such shift to be noteworthy unless they involve significant improvement in modeling skills against relevant observations. So in this case, the experts do not think that their probabilistic assessment would be greatly affected by the forthcoming evidence. But notice that this is mainly due to the nature of the evidence that they expect to obtain in the future, rather than any evaluation of the current evidence. Hence, to recapitulate, what I'm arguing is that if confidence is supposed to be a summary of the 3 factors mentioned in this proposal, it is unreasonable to suppose that the level of confidence has anything to do with the expert's assessment of how likely the consensus regarding appropriate credences is going to remain fixed in light of future developments, contrary to what Winsberg suggests. So, in a nutshell, how does this proposal fare with respect to my 2 desiderata? I think this proposal fails to meet the first desideratum because, as I've just argued, the imposition of confidence and its own proposal is conceptually problematic. And it arguably also fails the second desideratum because, without a clear and unambiguous imposition of confidence, it is not clear enough what role it should have in decision making. So this brings us nicely to a second, strikingly different proposals for new IPCC uncertainty framework by Bradley, Helgeson, and Hill. And their proposal stems from the very worry that it is not clear enough what role IPCC confidence assignments should play in decision making. And the reason they worry about this stems from the following observation. Decision makers are relatively comfortable with making decisions when faced with precise probabilities. In this case, they can, for instance, rely on the orthodox normative decision theory, expected utility theory. When it comes to imprecise probabilities, they're slightly less comfortable since there is no longer an orthodox normative decision theory on which they can rely. But there are nonetheless a host of decision rules that have been offered that can help them in these cases too. So far, so good. However, as Bradley, Helgeson, and Hill remarked, at first pass, the IPCC uncertainty framework seems far removed from models developed by decision theorists, since what the IPCC delivers are neither precise nor imprecise probabilities. Rather, what it delivers is imprecise probabilities qualified by qualitative confidence judgment. And Bradley, Helgeson, and Hill worry that it is not sufficiently clear what all these supplementary confidence judgments should play in decision making. Conveniently, however, they do find the one decision model that can deal with imprecise probabilities qualified by ordinal confidence judgment, often by Hill himself. And in light of this model, they claim to propose a simple mathematical model of the confidence likelihood relationship that resolves astounding ambiguities while respecting the qualitative nature of the confidence scale. Okay, so let's get to it. So according to their proposal, the assignment of an imprecise probability interval to a hypothesis should be determined by a well-defined set of probability distribution functions. So, for instance, assigning probability 0 to 0.1 to outcome X means that within the set of the PDFs collectively representing author's uncertainty, the smallest probability given to outcome X by any PDF is 0, and the largest probability given to X by any PDF is 0.1. However, there is a caveat. Each level of confidence should be associated with its own sets of PDFs, where higher confidence sets encompass lower confidence sets. So they give an example to illustrate how this is supposed to work. Suppose the author team starts with a set of possible PDFs concerning the value of the equilibrium climate sensitivity. Then the author team must then, according to this proposal, sort these PDFs into a confidence partition, which in this example is assumed to have 4 elements, N0, 2, and 3. So the PDFs in N0 are supposed to be those considered to be most plausible, according to the author teams. And then the PDFs in N1 collectively represent a second tier of possibility. The element in N2 is another step down from there, and N3 is the bottom of the barrel. All the PDFs more or less pulled out by the body of research that the experts evaluated. Now, these partitions of PDFs can then be used to generate a nested family of subsets of PDFs, L0, 12, 3. Well, Li is the union of M0 through Mi, and each Li is associated with a level of confidence. So, assuming that L0 corresponds to medium confidence and L1 corresponds to high confidence, the author team is now able to generate various probability statements at those levels of confidence. For instance, if the experts want to determine the probability interval that, say, that equilibrium climate sensitivity is greater than 6 at, say, medium confidence, so what do? All they have to do is check what probabilities the various PDFs in L0, so L0 is equal to M0 in this case, because it's about, so L0 is M0. So there's 2 PDFs in M0 and hence L0. And what they have to do is check what probabilities the 2 PDFs in L0 assign to that hypothesis, and then report the probability interval bounded by the smallest and largest of those probabilities. In this case, L0 contains 2 PDFs, and where one assigns nearly 0, and to the hypothesis that the equilibrium climate sensitivity is greater than 6, and the other one just assigns under 0.1. Hence, in this case, the other team should assign a probability range of roughly 0.01, which, according to the IPCC terminology, corresponds to very unlikely, and report The equilibrium climate sensitivity is very likely greater than 6, medium confidence. And the author team can then repeat this mechanical procedure to determine the likelihood level that should be assigned to various hypotheses concerning the possible values of the equilibrium climate sensitivity at any confidence level. So, Bradley, Harris, and Hills argue that their proposal clarifies the relationship between confidence and likelihood by providing a principled and transparent method that determines how likelihood and confidence levels interact with one another. They also argue that by showing how it can make sense conceptually to answer the same question on multiple confidence levels, this proposal gives confidence a clear role in decision making. What they have in mind, as mentioned earlier, is a confidence-based decision model proposed by Hill, which, according to him, can deal with imprecise probabilities qualified by ordinal confidence judgments. I would try to convince you in that very short time that their proposal actually is none of those things. So the main challenge that they acknowledge with their proposal has to do with the calibration of confidence levels between different author teams. That is, for their proposal, according to them, to work in practice, the IPCC would need to develop a proper calibration scale that would enable clear and unambiguous formulation and communication of confidence judgments across authors and actors. We want to take this proposal for connecting the IPCC and certain laboratory theories of decision seriously. One major challenge is to develop such a scale. And I agree that we want to take this proposal seriously, such a calibration scale would have to be developed. However, I will argue that under the only plausible interpretation of likelihood, this is an immensely more challenging task than Bradley, Helgeson, and Hill acknowledge. And so I would conclude that one should not take this proposal seriously. Surprisingly, nowhere in their proposals do Bradley, Helgeson, and Hill clarify what interpretation of probability they have in mind, and hence what kind of uncertainty the likelihood metric is meant to represent. I will argue there are at most two conceptually coherent interpretations of likelihood and confidence in this proposal, and that both are problematic because inapplicable to the IPCC, albeit for distinct reasons. So under the first interpretation, likelihood is supposed to is meant to express the IPCC author's imprecise estimate of the objective probability of an event, given the available evidence. So under this interpretation, the PDF with which this proposal's recommended procedure will begin is a set of possible objective PDFs for the random variable in question, and the IPCC authors are simply unsure about which one is correct. Under this interpretation, confidence has a straightforward Bayesian interpretation, for it can be understood as expressing the credences that the IPCC authors have in the hypothesis that the correct PDF is in a given set of PDFs. Despite being conceptually coherent, however, this interpretation has a fundamental problem, as Winsberg convincingly argues, and I won't try and argue this. So it relies on a misunderstanding of the role chances play in climate science, in particular, a misunderstanding of the interpretation of the PDFs published in the literature concerning the value of the equilibrium climate sensitivity and many other important climate variables. Hence, if this is the envisioned role for likelihood and confidence in this proposal, then it is not an appropriate one for the IPCC to begin with. Under a second, more plausible interpretation, likelihood is meant to express the range of posterior credences that IPCC authors assign to hypotheses given the available evidence. Hence, in line with the literature on imprecise probabilities, the set of PDFs with which this proposal's recommended procedure will begin is a family of posterior credences, the posterior credence functions that the IPCC authors assign to hypotheses given the available evidence. What about confidence? Here's where things get complicated. Under this interpretation, there are a variety of reasons why there might be multiple PDFs. It could be due to, for instance, uncertainty in the price or in the likelihood functions for each line of evidence or other things. And indeed, this is often the case in scientific applications of the Bayesian approach. For instance, consider Sherwood's recent and ambitious effort to combine various different lines of evidence with a Bayesian approach to arrive at a unique posterior PDFs for this equilibrium sensitivity, which I've mentioned earlier. Sherwood and colleagues acknowledge that the Bayesian calculation has several limitations, since it is based on one particular prior, assumes independence between lines of evidence, and makes no allowance for known unknown. And although they do test, they perform some number of sensitivity tests to explore these limitations. For instance, they consider how a different prior distribution would affect the posterior PDF. They admit that substantially more work will be needed to further explore these limitations. However, there is no mention, however, there is no mention of the feasibility nor of the desire to sort all the PDFs consistent with available evidence in a confidence petition of any kind, most of which have not even derived to begin with. Instead, the general hope seems to be simply that were one to fully explore these limitations, the resulting posterior PDF would only be modestly affected. And all this is not surprising, since to the best of my knowledge, nowhere in the literature on imprecise probabilities, nor in any scientific application of the Bayesian statistics, has there been any attempt to distinguish hidden functions that are consistent with available evidence in any principal way. Nor is it all clear how one would go on about doing this in the first place. It is also worth stressing that this is literally one of the first attempts to arrive at a posterior credence function for a climate variable given all the available evidence. So in light of this, I think it is unreasonable to assume that the IPCC are currently or will ever or will be anytime soon in a position to start with a family of credence functions that are all consistent with available evidence for various kind of variables of interest and sort them in a confidence petition as required by this proposal. Relatedly, nor is it reasonable to think it is possible to develop a proper calibration scale that would enable clear and ambiguous formulation and communication of confidence judgments across authors and actors. Hence, despite what one might be tempted to think that this proposal is trying to take IPCC practice as it is and make the minimal changes to connect this practice to with the most compatible normative decision model that can be found in the decision literature. This is not the case at all. This proposal, under the only plausible interpretation of likelihood, is in fact drastically disconnected from the practice of the IPCC, and there is absolutely no easy quick fix to make it any more connected anytime soon. So, before concluding, this assessment, I just want to mention that although Bradley, Hill, and Anderson do not clarify how one should interpret likelihood in their proposal, they do offer an interpretation of confidence, one that seems more closely related to the current IPCC confidence metric, in contrast to the two interpretations that I just offered. Here's what they say. When used in conjunction with likelihood, we understand confidence to express something like Keynes' weight of evidence behind a probability statement, where the weight he refers to includes the quantity, quality, and diversity of evidence underpinning a claim. However, this interpretation of confidence is not consistent with other interpretations of likelihood that I've discussed. Consider, for instance, the second interpretation, under which the set of PDFs is the family of posterior credence functions that the IPCC authors assign to a hypothesis given the available evidence. Under this interpretation, any subset of PDF whatsoever is based on the available evidence and hence the very same evidence. So if we interpret confidence as something like Keynes' weight of evidence, then any subset of PDF have to be assigned the same level of confidence. And this is incompatible with this proposal. Therefore, despite their suggestion on how we should interpret confidence in their proposal, I see no reason to take their word for it. How does this proposal fare with respect to my desideratum? I believe it absolutely fails to meet the first desideratum because, as I've just argued, under the only plausible interpretations of confidence and likelihood and the likelihood metrics, they cannot be appropriately and consistently used by the IPCC authors in their communication uncertainty. And I also happen to believe that it is bound not to meet the second desideratum because I think his own normative account of belief and decision making on which this proposal is based is ill-founded. But I won't be able to do justice in this talk, but I'm happy to discuss it. So in light of how much time do I have? Okay, I knew that I would run out of time, but what I was gonna do, I will give a very tentative proposal. So I'm actually kind of happy that I don't have to share mine. And that would satisfy this desiderata. I wanted to discuss with probability. It's very useful, but we should be careful. And the IPCC. No, okay. I was going to give you a history of the IPCC and show you the radical revisions that have been made. And okay, and then what I was going to do? I was going to compare. Okay, no, look, I've got 30 seconds. Let me. I'll just give you the two key things. So I do think, like Winsberg, that the lack of metrics should be used to communicate the range of credences that are satisfactory to almost all, if not all, of the members of a panel, given the available evidence, roughly. And however, I think, given this interpretation, we should think carefully about the ranges of probability that would determine a particular likelihood level. This was from the very first uncertainty guide, and you see that the intervals don't overlap with one another. And I think this difference is significant because currently the IPCC would be forced to assign, for example, a probability of 0.9 to hypothesis, even when they would roughly just want to assign it 0.7. So in light of this, I was going to propose my graph likelihood scale, and then I would say get rid of confidence. Was too much trouble, and anyone who has said anything about possible interpretation of confidence has not said anything conceptually coherent about it, and that's why I think we should get rid of it. And then that's it basically. So I think I'm fine.